Hello everyone. Through this video, let us know more about the short peening activity and its procedures. Short peening is a cold working process used to produce a compressive residual stress which can prevent fatigue and stress corrosion failures and prolong the product life. It entails striking a surface with shot with force sufficient to create a plastic deformation. Short peening is used across a wide range of industries to improve the surface properties of the component, including the medical, aerospace, and automotive field. Examples are on the gear parts, the camshaft, connecting rods, gear wheels, pistons, drill bits, turbine wheels, and landing gears. The process is also widely used to relieve the tensile stresses created through work hardening in aircraft repairs. Where processes such as grinding can create the tensile stress, short peening can replace these with the beneficial compressive stresses. Before we start the short peening process, we should make sure the object is free from all debris and proper masking is given to other places where the short peening is not required. Here we have used a control panel to vary the RPM of the turntable, keeping the nozzle fixed and moving across the object. The peening media that we have used here is a cast steel shot. The other peening media that can be used are ceramic or glass beads and cut wire. The main advantage of short peening is to extend the service life of a component by creating an induced compressive stress layer to increase the resistance to fatigue while also helping to resist the development and propagation of cracks. An Alman test is a crucial component of a controlled short peening process because it measures intensity. Intensity is a measure of energy of the short stream, and the energy of the short stream is directly related to the compressive stress that is peened into a part. Therefore, assessing the intensity is one of the essential means of ensuring process repeatability. Alman test is carried out with the help of Alman strip, Alman gauge, and an Alman fixture. An Alman strip is a thin strip used to quantify the intensity of a short peening process. The strip is placed using a special fixture, usually near an area where the short peening has to be done. The compressive stress induced by the peening operation causes a strip to deform into an arc, which is measured using an Alman gauge. A method to measure the effect of short peening was created by John Alman, who devised the Alman strip to measure the compressive stress that are imparted by the process. The intensity of the short stream can be measured in the deformation of the Alman strip. This is done as the strip reaches 10% deformation and it is then hit with the same intensity for double the time. If the strip is seen to deform by a further 10%, the intensity of the blast stream can be measured. Saturation point and intensity values are determined by establishing the saturation curve. Each strip is short peened for a different time. The deformation caused by each strip is the measure of the arc height. Now, with these observed values, we plot a arc height versus exposure time graph. Using this graph, we get the saturation point. Short peening is commonly undertaken using manual blasting system or the centrifugal blasting wheels. The manual blasting system uses a high pressure air to fire the shots through a nozzle at the workpiece. In this video, you can see we have used a manual blasting system where the nozzle is held in a fixed place and the object is turned using a turntable.